All right, so another review from Chem 101, electron configurations. So remember, if we draw our periodic table, as we go down these rows, our n increases, right? So n increases from 1 all the way down to other numbers, right? And then here we have our transition metals. So don't forget about our transition metals. Here we count n minus 1. And then our inner transition metals are n minus 2. And then also don't forget that these transition metals, they actually get inserted right into here. So the real periodic table actually looks something like this. Right, where our transition metals are over here, and then our inner transition metals are over here. So if you use this website, pt2.com, it's super duper useful. If you go over here and just click this wide section, check out what happens. You can see they insert those elements to get the real kind of periodic table. But since too many people don't mess with the inner transition metals, we keep it unwide and to keep it on kind of one sheet of paper. So again, this is a review, so I'm going to go through it relatively quickly. Let's just take a look at electron configuration for some of our transition metals. Let's start off with titanium. Titanium is right there. And so you could pick up its the noble gas above it to start off with. So titanium has the same electron configuration as argon. And then we have these 2s electrons, so these 4s2 electrons. And then we have 2 d electrons, so d2. And then remember, all of this is n minus 1, so this becomes 3d2. So for titanium, it's 3d2. And then if you're thinking about what the orbital diagram is, you have this 4s orbital totally filled, and then you have 5 d orbitals, and we have 2 electrons in there, right? Both spin up and both on their own. So review Chem 101, electron filling, that kind of stuff, if this is unfamiliar. Also, don't forget that chromium and molybdenum are exceptions. If you look at their electron configuration, it's whatever noble gas you have here, then ns1, n minus 1, d5, right? So one of these s electrons goes into the d orbital to get these half-filled shells. And same thing for copper, silver, and gold. They're also ns1, but this time they're d10. So again, an s electron has gone into the d orbital. And then also don't forget for transition metals down here, before you can get here, if you're reading your periodic table like a book, left to right, line by line, let's see what happens. So silver or gold, I bet gold. Down here, the noble gas above it is xenon, so it has the same electronic configuration as xenon. And then we're going to read the periodic table like a book, left to right, line by line. So after xenon, you have these 2 6s electrons, so 6s2. And then you don't go straight into the d electrons, right? You got to come down here first and take care of all of these f electrons. Remember, f is n minus 2, so it becomes 4f14. And then after that, we can go into our d electrons, so 5d9. And then remember that it's an exception. So one of these electrons is going to hop over here. And so the electron configuration becomes 4s1, 5d10 at the end. So review Chem 101. Remember, if you have a periodic table for electron configurations, you can just read it like a book, left to right, line by line. Another thing you want to remember from Chem 101 is when transition metals form ions, what do they lose? And they lose the s electrons first. So for example, iron is like argon, then 4s2, 3d6. If we think about iron 2+, it's now lost 2 electrons, so still like argon, but instead of losing the d electrons, it's going to lose the s electrons first, so it's 3d6. So all that should be reviewed. If you have any kind of concerns, review some stuff and let me know.